15:30 hours. Levi Stadium, Santa Clara, California. The national anthem is ending. 60,000 people in the stands are looking up, waiting for the sound that precedes the image. The distinctive low roar of afterburners that means F-22 Raptors are about to cross the stadium at low altitude. The Air Force had confirmed the flyover. 2 Raptors, the most capable air superiority aircraft ever built, were on the program. What crossed the sky instead was a pair of F-15C Eagles from the California Air National Guard. Capable aircraft. Not what was announced. The Air Force Public Affairs Office issued 4 sentences. Operational tempo, last-minute reallocation, no further detail available. The statement was accurate in every word and disclosed nothing that mattered. Those 2 F-22s were already supersonic over the Pacific, climbing through 50,000 feet, burning toward the Persian Gulf on a timeline measured not in hours, but in the window between what Iran had already set in motion and what was still possible to stop. At 0200 hours local Gulf time, timed precisely to the moment American attention was maximum concentrated on a football game, Iran activated an electronic warfare architecture that had been pre-positioned across the northern Arabian Sea over the preceding weeks. The scale of the activation was not routine jamming. It was a simultaneous coordinated emission across multiple frequency bands, structured to saturate the AN/SPY-1DV radar systems of the 5th Fleet's escort destroyers in under 60 seconds. The Aegis combat management systems on those destroyers did not go dark. Something more operationally dangerous happened. The radar picture degraded into a state where the system could not reliably discriminate between real inbound contacts and the interference-generated noise filling the same frequency space. A radar that shows nothing is a known problem. A radar that shows everything as equally probable is a targeting system that has been turned into a liability. 300 Shad, 136 loitering munitions were already airborne before the jamming activated. They had been launched from positions that kept them below the radar horizon of the carrier group's outer escort screen, flying nap-of-the-earth profiles that kept their radar cross-section buried in surface clutter. By the time the Aegis systems registered the threat, the formation was inside the outer engagement envelope. The Phalanx Block 1B close-in weapon systems on the escort destroyers began cycling. The drones were not flying direct attack profiles. They were holding wide orbits, transmitting radar-mimicking signatures designed to trigger the Phalanx's autonomous engagement algorithm, forcing the system to expend 20mm rounds against decoy signatures while depleting the burst capacity that would be needed when the real terminal phase attack came. Each false engagement cycle the drones induced was inventory the defense could not get back. Behind the drone swarm, running under MCON Alpha with every transmitter dark, more than 100 IRGC fast attack craft were accelerating across the Gulf surface on direct bearings to the carrier group. No radar, no radio. They were navigating by the muzzle flashes and tracer fire from the ships they were targeting, using the defensive engagement they had provoked as their own navigation aid. At 40 nautical miles and closing at 50 knots, the geometry was precise. If the fast boats reached 20 nautical miles before the drone swarm was neutralized, the density of targets would exceed the Phalanx's engagement rate. The math had been calculated in Tehran before the operation launched. The economic logic of the attack was its most precise element. Each Shahed 136 costs approximately $20,000 to produce. Each SM-2 Block 3C missile expended against one costs $2 million. Iran had launched enough drones to force the 5th Fleet to choose between depleting its VLS cells at a 10-to-1 cost ratio or allowing the swarm to penetrate to attack range. Both options closed a path. Both options were part of the design. Rear Admiral commanding the carrier group activated Blue Shield. FA-18, E-Super Hornets, and F-35C Lightning IIs launched off the Abraham Lincoln's deck in sequences that compressed the standard safety intervals, establishing a forward defensive screen using onboard infrared sensors rather than the ship's degraded radar as the primary targeting feed. The AIM-9, X-Sidewinder's imaging infrared seeker, does not need a radar handoff. It can acquire a target from its own passive sensor against the thermal contrast of a drone airframe against sky. The initial engagements worked. The sea ahead of the formation began filling with orange bursts as loitering munitions came apart under missile intercepts and 20mm cannon fire. The problem appeared when the engagement geometry forced the pilots beyond visual range. past the visual identification threshold, engaging targets requires active radar to generate the precise targeting data the AIM-120 AMRAAM's semi-active guidance needs in its terminal phase. The moment the F-35C pilots activated their AN/APG-81 radar systems, Iran's electronic warfare architecture responded. The jamming pattern shifted from broadband interference to precision frequency hopping attack, tracking the specific emission frequencies of the American radars and modulating its interference to break the radar's tracking coherence mid-engagement. AIM-120S went blind after launch. The missiles that did not veer into the sea detonated against Iranian chaff blooms rather than the contacts they had been tracking. The F-35C carries 4 AIM-120AS internally, the capacity limitation imposed by its stealth requirement. An internal weapons bay that does not compromise the aircraft's radar cross-section is physically constrained. 4 missiles per aircraft against a 300-unit drone swarm and a 100-plus fast boat formation depleted in minutes of sustained engagement. When the internal magazines were spent, the pilots had 2 options: return to the carrier for rearming or transition to close-in gun runs that put the aircraft inside the engagement envelope of the fast boat's defensive weapons. The defensive screen began developing gaps. Iran's final preparatory layer activated as the F-35s were pressed to lower altitudes for close-range engagements. From hardened facilities inside the Zagros mountain range, a network of high-power VHF radar systems came online. The frequency selection was specific. VHF operates at wavelengths long enough to interact with the physical dimensions of an aircraft fuselage in a resonance effect that standard radar-absorbent material geometry cannot suppress at all aspects. The F-35 stealth architecture, optimized for X-band and Q-band radar frequencies, does not provide the same cross-section reduction against wavelengths that are on the order of the aircraft's own structural dimensions. The radar warning receivers in the F-35 cockpits registered lock-on tones from bearings they had not been watching. The Bavar 373 surface-to-air missile batteries that had been passive since the engagement began launched 12 Sayad 4B missiles simultaneously. The missiles were not aimed at the Abraham Lincoln. They were targeted at the F-35C formation, aircraft that were now low on fuel after sustained close-range engagements, whose fuel states created a constraint on their evasive maneuvering options. The pilots executed emergency defensive brakes, jettisoned external fuel tanks, and pushed their aircraft toward the sea surface to break the radar lock in the ground clutter layer. They survived. The defensive perimeter above the carrier group did not. The sky over the USS Abraham Lincoln was open. The fast boats that had survived the initial air engagements were inside 20 nautical miles and still closing. The phalanx systems were engaging, but against more than 100 simultaneous surface targets at combat range, the close-in weapon system's engagement capacity was a finite number against an infinite-feeling problem. At 60,000 feet, traveling at Mach 1.5 on Super Cruise, supersonic without afterburner, which means supersonic without the infrared signature that afterburner produces. 4 F-22 Raptors crossed into the operational area. They had been in the air for hours. They had refueled twice from KC 46 tankers. They had not transmitted a single electronic emission during their entire transit. The F-22 Raptor's AN/ALR-94 passive receiver system is not a radar. It does not emit. It collects a wideband passive electronic sensor suite that characterizes every radar emission, every communication signal, and every electronic system operating in the surrounding airspace, and builds a precise picture of the electromagnetic environment without broadcasting its own position to anything listening. The VHF radar stations in the Zagros that had just forced the F-35s off the defensive line were transmitting. The fast boat command and control network was transmitting. The drone coordination frequencies were transmitting. Every active system Iran had brought to bear on the engagement was advertising its own position to a sensor that needed no emission to see it. The F-22 does not have a large internal weapons load. 4 AIM-120Ds and 4 AIM-9Xs. Against 300 drones and 100 fast boats, that infantry does not solve the engagement numerically. It does not need to. The multifunction advanced data link, the F-22's intraflight data bus that extends to ground and naval receivers, began transmitting targeting packages. Precise coordinates updated continuously from the ALR-94's passive picture for the fast boat formation and for the VHF radar nodes that were keeping the F-35s suppressed. Those coordinates went 2 directions simultaneously. to an F-15E Strike Eagle squadron holding low over the Gulf surface outside the Iranian radar coverage arc, carrying loaded racks of advanced precision kill weapon system laser-guided rockets. The APKWS is a 70mm unguided rocket with a laser guidance kit. Cheap, accurate at the ranges involved, and carried in quantity that a 5-missile VLS constraint does not produce. The F-22s overhead were not shooting at the fast boats. They were illuminating them with radar targeting data, passing precise coordinates to Strike Eagles that fired from distances the fast boat crew's defensive weapons could not reach. The boats began detonating without ever seeing an aircraft above them. Simultaneously, the VHF radar station coordinates went to the Aegis systems of the escort destroyers. Tomahawk Block 5 cruise missiles launched from the VLS cells, not at the fast boats that were the visible threat, but at the mountain installations that were keeping the carrier group's air defense blind. The missiles flew terrain-following profiles through the Zagros passes and arrived at radar vehicle positions that the F-22's passive sensors had resolved to within meters. The radar warning receivers in the surviving F-35 cockpits went quiet. The VHF locks broke. The sky reopened. Then the E-3 Sentry's voice cut across every command frequency in the operational area. Vampire, Vampire, hypersonic inbound. From silos in the Zagros range, Iran had launched 3 Fatah-2 hypersonic ballistic missiles. The Fatah-2 follows a depressed trajectory that spends most of its flight below the engagement altitude assumptions of standard surface-to-air missile batteries, reaches terminal velocities around Mach 13 to 15 depending on re-entry geometry, and executes glide phase maneuvers that make pre-computed intercept solutions obsolete by the time they are generated. Against a standard Aegis intercept profile, the geometry is genuinely difficult. Not impossible, but difficult enough that Iran had made the calculation that deploying it as the operation's final layer would arrive at a point where US defenses were too depleted to respond. The intercept solution the F-22 squadron leader identified was not the standard terminal intercept approach. It was the boost phase. A hypersonic missile immediately after launch is not hypersonic. It is a large, fuel-heavy ballistic object accelerating through its boost phase, moving relatively slowly by the standards of what it will become, generating an enormous infrared signature from its sustainer motor and following a predictable ballistic arc before it initiates glide maneuvering. The window is measured in seconds. Catching it requires being positioned above and ahead of the launch point at the moment of launch, a condition that the F-22s, cruising at 60,000 feet over the Zagros range, happened to satisfy. 2 F-22s pushed nose down into a full afterburner dive from 60,000 feet. The descent was not to get closer to the missiles. It was to build kinetic energy, adding their own Mach 2.2 velocity to the AIM-12 OD's Mach 4 motor, compounding the closing speed to the point where the combined approach vector could reach the boost phase window before it closed. The AN/AAQ-37 distributed aperture system's infrared sensors locked onto the motor plume signatures rising through the mountain smoke. At 80 kilometers, the salvo launched. 6 AIM-120Ds, each already carrying their own Mach 4 velocity, compounded by the launch aircraft's Mach 2.2 dive. The E-3 Sentry scope showed 2 contacts going from active track to debris cloud in the space of 3 seconds. The kinetic energy of the collision between interceptor and boost stage at combined speeds exceeding Mach 6 did not produce a contained warhead explosion. It produced a structural disintegration event at an altitude still above the Zagros range. The third missile, caught in the shockwave propagation from the 2 simultaneous fragmentation events, lost aerodynamic stability and corkscrewed into uninhabited desert. 3 hypersonic missiles, launched from Iranian soil, destroyed over Iranian territory by an aircraft that Iran had never acquired a targeting solution on. The ceasefire request came on a non-standard frequency within 4 minutes, not through diplomatic channels, not through a formal communication, on an open military frequency, an instruction to surviving IRGC assets to disengage and return to port. The fast boats that had penetrated to close range turned and accelerated back toward Iranian waters, leaving the burning remnants of the craft that had been destroyed behind them. The surviving drone formation dispersed. The Bavar 373 batteries shut down their radars and retracted into hardened shelters. The VHF radar stations went dark. The 4 F-22s climbed back to cruise altitude, connected with the KC-46 tankers that had repositioned during the engagement, topped off their fuel, and flew back toward Al Udeid on the same emission-silent profile they had used on the inbound leg. No press conference, no official acknowledgement, no photographs of the aircraft over the Gulf. The USS Abraham Lincoln continued north. The carrier strike group reformed its escort geometry and resumed patrol. The failing systems were reloaded, the VLS cells were inventoried, and replenishment logistics activated. A maintenance crew was dealing with two F-35Cs that had sustained battle damage during the low-altitude engagements. All pilots accounted for. At Levi's Stadium, the Super Bowl concluded normally. The crowd dispersed into the California night. The F-15Cs that had flown the flyover had performed professionally, and no civilian watching had any reason to think the absence of Raptors was anything except a scheduling adjustment. The Central Command website posted a 4-sentence statement about defensive measures and elevated alert posture. The statement did not mention the Fata-2 launches, the fast boat engagement, the drone swarm, or the F-22 operations. It was accurate in what it said. It omitted everything that had actually happened. What Iran discovered in this engagement is structural rather than tactical. The saturation attack model, overwhelming a point defense with volume and cost asymmetry, works against a fleet that is defending from its own sensor picture. When the sensor picture is compromised by jamming, the calculation that governs when SM-2 inventory becomes critically low is accurate. When the defensive screen is suppressed by VHF radar illumination, the gap that opens above the carrier group is real. What the model did not account for was a platform that operates entirely outside the electronic environment the attack was designed to collapse. The F-22's passive sensor architecture does not emit. It cannot be jammed because jamming requires something to jam. The ALR-94 built its targeting picture from Iran's own transmissions. The VHF radars, the boat control networks, the drone coordination frequencies, all of which were necessarily active because the attack required them to be active. Iran's attack depended on electronic warfare suppressing U.S. active sensors. The F-22 does not use active sensors as its primary targeting input. It used Iran's own emissions as its targeting feed, then distributed that picture to platforms with the weapons inventory to execute against it. The Fata-2 launches were the clearest demonstration of the miscalculation's depth. A hypersonic missile designed to defeat intercept systems that engage in terminal phase is genuinely difficult to intercept in terminal phase. Engaging it in boost phase requires being above and ahead of the launch point at the moment of launch, a condition that depends on having an asset in that airspace before the decision to launch is made. The F-22s were there because they had been there since before the engagement began, invisible to everything Iran was using to track the operational area. The decision not to publicly acknowledge what had happened was itself a message. An Iran that knows its hypersonic missiles were intercepted in boost phase over its own territory must update its threat calculus. An Iran that cannot be certain what else is overhead and operating in what modes faces a targeting problem it cannot solve through electronic countermeasures. The empty sky over Levi's Stadium at 15:30 hours was not a scheduling gap. It was a deliberate signal. Deniable, interpretable, and understood by the people it was directed at. The F-22s that should have been flying a stadium pass were in the process of ensuring that the game being played several thousand miles away could end without the world learning how close the situation had actually come. The biggest unanswered question in the aftermath of this engagement is not tactical. It is architectural. If Iran determines that conventional hypersonic delivery is no longer reliable as a deterrent, and the threshold for what gets loaded into those Zagros silos shifts, that is the scenario that does not resolve through F-22, Super Cruise, and AMRAAM boost phase intercepts alone. That is the scenario the B-21 Raider exists for. And that conversation is one no one in a position to have it is currently willing to have publicly. The stadium lights went off in Santa Clara. Somewhere over the Arabian Sea, 4 Raptors were drinking fuel from a tanker at 35,000 feet, heading home in the dark. If this breakdown gave you a clear picture of how layered multi-domain operations function under the most compressed combat timelines imaginable, subscribe and share it. More of these analyses keep coming as long as you are here for them.